Hi everyone, Mrs. Casey here. Today we are going to continue talking about solving rational inequalities using the number line method. These problems are on the handout from yesterday, so if you have that handy, you might want to grab it so that you can go through the problems faster with us. All right, this first one, we need to start by getting 0 on, one of the sides. So I'm going to move the 6 over x to the left, and I'm here. Now, in previous math classes, one of the things you would have done as a way to solve this if it were an equation were to multiply by the common denominator. I'm going to recommend that you not do that here because what happens is then you lose that denominator, and sometimes we forget that we need to take that into account when we're using the number line method. So as you see me finish up the problem, I want you to pay attention to why I am not multiplying by x and instead am getting a common denominator. All right, so my common denominator is x, so I need 6x squared here. And for some reason, I'm struggling to write in certain spots on the screen. And then this is minus 5x, and then minus 6 over x, okay? So then this becomes x in the denominator, and then 6x squared minus 5x minus 6 in the numerator. It doesn't change what you would have gotten. So the numerator is what you would have gotten if you had multiplied the whole thing by x. So that doesn't change. It's just allowing you to remember that there's this x that has to still be part of the problem. I am going to factor this, and this factors into 2x minus 3 times 3x plus 2, still all over x, less than, I randomly threw in an equal to there. That is not true. Just less than 0. And then now all 3 of these values are going to go on my number line to test. I have a negative 2/3, 0, and 3/2, and I'm going to check in each of those 3 regions that I created. But I do know no matter what, all of them are open circles because of the less than sign. Okay, when I check to the right of 3/2, like a 2, I get positive. When I check between 0 and 3/2, like 1, I get negative. And then it continues this way, positive, negative. Feel free to check those all on your own if you need to. I am talking about values less than 0, so I need all of the negative regions, which there are 2 of them, which gives me a final solution of negative infinity to negative 2/3 and 0 to 3/2, everything parentheses because of the less than sign. Okay, next problem, number 8 here. Similar situation. I am going to move the 3 to the left, so minus 3, so I can have a 0 on the right-hand side. And I need a common denominator of x minus 4, so I'm going to go ahead and multiply the numerator by x minus 4 as well. This means I now get x minus 4 in the denominator of one fraction, and I'm going to go ahead and distribute the negative 3 and not forget to distribute it also to the negative 4. Now I combine like terms. I get negative x plus 9 over x minus 4 less than or equal to 0. Factor out the negative if you'd like. It won't change how you solve the problem. We have 2 zeros that go on my number line. I have 4 from the denominator and 9 from the numerator. My 4 gets an open circle because it's in the denominator, but the 9 gets a closed circle because of the less than or equal to symbol in the problem. And now we're testing. And when I test, I get negative over here, positive here, negative here. And again, on this problem, I want the negative values. Here is my solution on the number line, which gives me an in interval notation, negative infinity to 4 with a parenthesis, and then 9 to infinity with a bracket. I don't know why it is doing this. Let's try that again. Bracket in parenthesis. Doesn't like me today. That's parenthesis, can you tell? Okay. If you're not sure if your answer makes sense, or if you just want to check to make sure that it is making sense for you, go back up to the top and substitute a value in. So substitute a value from the region. I'm noticing I put -4 here, sorry. So let's say I want to check, I know that 10 is within this region, so I'm going to go up to the top and I'm going to substitute 10 in. When I put 10 into this problem, I get 20 minus 3 is 17. 10 minus 4 is 6. So I get 17/6, which is actually a little bit less than 3. So 10 works, which means anything within that region will work as well. So I'm confident with that part of the problem. So feel free to use that method of picking a value and going back to the original problem to see if it works. All right, a few word problems here. This first one says, for what positive numbers will the square of a number exceed 3 times the number plus 2? So positive numbers means that my solution set should be greater than 0 when I'm done. So I've already put a little domain restriction on the problem. Okay, the square of a number, so my number is x there, the square of a number exceeds 3 times the number plus 2. I am now going to bring my 3x to the left and my 2 to the left. And I'm stuck with something that doesn't factor, which never makes any of us happy, but that's okay. I can always resort to my good old quadratic formula. So I get -b plus or minus square root b squared minus 4 times a times c all over 2a. And this simplifies into 3 plus or minus square root of 17 over 2. Okay, so 2 answers, 3 plus and 3 minus. And so it really just depends on how big the square root of 17 is on if I need both of these values. So square root of 17 is a little bit bigger than 4 because it's a little bit bigger than the square root of 16. So if I think of this as 3 minus 4, that's going to give me negative. So I don't actually want the negative answer. I only want the positive answer. So when I check on my number line, I am checking starting at 0 and then using 3 plus root 17 over 2. And using the about 4 is a good choice to help me figure out what's going on. So 3 plus 4 is 7 over 2. So about 3.5. This is about 3.5. So I'm just going to pick 1 to check. And I'm just going to put 1 over here to see if it's bigger than 0. I'm going into this spot. So 1 minus 3 is a -2. Minus 2 is a -4. So this region in here is negative. And then pick something to the right of, like I said, about 3.5. Anything would work, like let's say 10. If I put 10 in for x, I get 100 minus 30 minus 2, clearly positive right there. So I am looking at this region only because of this domain restriction. So my answer is from, that I want a parenthesis, sorry, because it says exceeds, so I only want the parenthesis, 3 plus root 17 over 2 to infinity. Okay. Next. Number 10. For what numbers will the cube of a number exceed 9 times the number? So there is our setup. This one's even, I think, a little bit easier than the one we just did, because when I pull the 9x over, I can factor out an x, and I'm left with x squared minus 9, which also factors nicely. So I have 3 values I'm interested in here. X times x plus 3 times x minus 3. So on my number line, I have -3, 0, and +3. And testing within each of the regions, so to the right of 3 is a positive, and because each of these zeros all have multiplicities of 1, these are all bounce points, which means this 3 here starts at positive and has to cross down into the negatives and then cross back up and come back down. So you automatically know that this is going to switch back and forth. Another thing you could think of it is this is x cubed minus 9x. So the original problem is a cubic function with a leading coefficient that's positive. So that means that the graph would start down here in the negatives on the left. So it would go, maybe if I even do a quick sketch, it's doing something like this. Okay, so positive, negative, positive, negative. I'm just reminding you that is another option when you're doing this number line test. We want greater than, so then our solution is -3 to 0 or 3 to infinity. All right, moving on. The next one then has basically two rationals on its own. You are welcome, if you wanted to graph this one and graph this one. So graph the one on the left and one on the right and figure out when is the one on the left greater than the one on the right. But that's a lot of graphing work, and I don't know that it's even all that easy to do because they're not always going to be whole number answers. So you do have to be kind of conscious of when you make your decision, is it worth your time to graph it? Okay, I can't multiply through by the denominator because that's going to cause me to lose these zeros in the denominator. So instead, I have to get a common denominator in both fractions. This is 3x minus 2 times x minus 1 minus x minus 2 times x minus 4 all over x minus 4 times x minus 1. I'm definitely going to run out of room, so I'm probably going to need to use space going down into number 12, and then I'll copy number 12 over. See if I can move it. I can't. So I'm just going to pretend that it's not there and ignore it for right now. Okay, so now I'm going to distribute, or FOIL, whatever you guys learned it as. I get 3x squared minus 5x plus 2. And here is the number one mistake of students, is they neglect the negative out front there. This is going to become minus x squared plus 6x minus 8. And my denominator is going to stay factored because I needed to use those numbers for the number line method. This simplifies into 2x squared plus x minus 6 all over x minus 4 times x minus 1. Look at all this algebra occurring here. And this factors into 2x, let's think here, minus 3 times x plus 2. I think that's right. X minus 4 times x minus 1, all greater than or equal to 0. I now have 4 numbers I'm going to test on the number line. And I'm going to go in the correct order so I don't mess up my windows here. So I have a -2, then a +1, then 3/2, and then 4. And the ones in the numerator, so the 3/2 and the -2, those are closed circles because of the less than. But the 1 and the 4 are open circles because they're in the denominator, and those are always open. And I'm going to just start testing values again. And it should do the same thing, switching from positive to negative, because everything has a multiplicity of 1. But again, if you're not comfortable with that idea, then you just start testing. So I'll test a couple values here, like I'm going to test 5. If I put 5 in here, I get positive, 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 positive. So positive. This should go negative, positive. I like 0, so I'm going to test 0 as well to see if that works out. So put 0 in for x, I get negative times a positive, negative times a negative. So I have 3 negatives and a positive, which means I have a negative. And that's good because that's what I was thinking it was going to be. Okay, here's my solution set, the greater than stuff right in here. This solution set becomes negative infinity to negative 2 with a bracket. 1 to 3 halves. So the 1 has a parenthesis and the 3 halves has a bracket. And the 4 has a parenthesis to infinity. Okay. All right, I hope that one's good. Moving on. I'm going to skip number 12 actually, because we did one very similar to it on the previous slide. So I think you can figure this one out. I will tell you though, let me just tell you the answer. So if you want to try it, you do get this as an answer, negative infinity to negative 5/4, or 0 to 1. Okay. 13 looks like the most complicated, but it is actually the easiest one because it is already factored for you. You just have to figure out all of the zeros that you need to put on the graph. So it looks like the smallest number is negative 6, which is an open circle. Then will come negative 7 halves. They're actually all open circles because it's just a less than. Negative 7 halves. Then we have 0. Then we have 3, and finally 5. And I have to test each region, or I'm going to use some of these multiplicities to guide me, okay? I'm going to start either all the way on the right or all the way on the left because that'll help guide me a little bit. If I start with 5 to the right of 5 and I put something like 6 in, I get positive, 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 all positives. And a 5 is a vertical asymptote, and the multiplicity is odd, which means if it's positive on the right side, it has to be negative on the left. So that region is negative. Then I'm going to now think about 3. Well, 3 is a 0, and it has an odd multiplicity as well, which means it's a cross-through point at 3. So that means on the other side of 3 in this region, it should switch back to positive. But again, if you're not confident in that, you stick a number in there. So like 1. If I put 1 in for x, I get positive, negative, positive, positive, negative. So these two negatives cancel out and become positive. All right, 0 is an odd multiplicity because it's x cubed. So that means on the other side of x, we will also be switching signs. So we're going to go to the negative there. Negative 7 halves is an odd multiplicity. It's to the first power. So we're going to switch signs on the left-hand side of that as well. So this is going to become positive. And then 6, or negative 6, is the only even multiplicity, which means that although this is a vertical asymptote, on both sides of the vertical asymptote, we are going in the same direction. So on this side, we're going up to positive infinity. So on the left side, we're also going to go to positive infinity. Don't believe that, don't remember that, stick a number in, like negative 10. If I put a negative in, negative 10, and I get negative times a negative times a negative times a positive times a negative. So I have 4 negatives, which makes a positive, and then another positive there. All of that work to figure out that the solution is just this little window of values here. So from negative 7 halves to 0, and from 3 to 5. Again, I was talking about the multiplicities, but feel free to just keep substituting values in. All right, I think number 14 is our last one. Yep, and it is a long one, so I'm going to get myself some space here. I need to get a common denominator, and I also need to move the 1 to the left. So my common denominator for the first fraction will be x minus 1 times x minus 3. So the numerator needs an x minus 3. The second fraction needs an x minus 1. And the third fraction needs both an x minus 1 and an x minus 3. Okay, I'm going to distribute everything, not the denominator, but everything in the numerator. I get 2x squared minus 5x minus 3 minus 2x plus 2. I'm going to multiply out the x minus 1 and the x minus 3 and the negative here all at the same time. This becomes negative x squared plus 4x minus 3 all over our denominator of x minus 1 times x minus 3. And this is all less, not equal to, less than 0. When I'm done with this video, I'm figuring out what is going on with my stylus or something here. Okay, combining like terms in the numerator and then factoring, and hopefully this doesn't turn out to be too difficult here. So combining like terms actually gives me, let's see, x squared minus 3x minus 4, I think, yep, all over x minus 1 times x minus 3. And this factors into x minus 4 times x plus 1 all over x minus 1 times x minus 3. And number line test. But again, it's these four factors that all have odd multiplicities. So this is just going to switch between positive and negative again. So I have a negative 1, positive 1, a positive 3, a positive 4, all open circles because of the less than sign. And I just need to test one region and then everything else should fall into place. So if I test something to the right of 4, like 5, I get positive, 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 positive. All 4 of those things are odd multiplicity, so everything should change back and forth between positive and negative. I only want the negative stuff. So my final solution to that problem is negative 1 to 1, 3 to 4. All right, I hope that makes sense. Please make sure that if you do have any questions, you write them down or put them in the question document. And see you soon.